Hi everyone, in today's video I would like to explain a little bit how you can use fully open source large language models locally without any internet connection. So I want to talk a little bit about LM Studio, which is a pretty nice UI. So it's a user interface to start chatting with one of the available open source models. So if you go to huggingface.com/models, you will find, as you can see, nearly 2 million models now that are openly available on the Hugging Face website. You can filter them on all kinds of tasks that you might be interested in, like computer vision models, natural language processing models, speech recognition models, and so on. So across all these domains of AI, there are hundreds to thousands of models available. And of course, nowadays, there's a lot of interest in large language models. So these are models, well, at least the initial large language models, they only took text as an input and produced text as an output. On Hugging Face, you can find these by filtering on the text generation tag. And then you see, for example, that there are about 250,000 different both pre-trained and fine-tuned large language models on the hub, with a model from Minimax currently training. And oftentimes, yeah, you can directly try it out in the browser. Like in this case, you can say hi, and this is using inference providers, which is a new solution offered by Hugging Face, very similar to the OpenAI API. So Hugging Face inference providers, yeah, it's serverless inference, so it means that someone else is hosting the model for you, and you can just send requests to it, and you get charged based on the amount of input tokens and the amount of output tokens that you get back from that server. And there are multiple providers out there, like in this case when I'm trying out this model. You can actually see the inference providers that support this model. So in this case it's only one, which is the Novita company. And as you can see, it also has this drop down for the reasoning tokens, and then this is the answer that you get. And you can then also actually click on the code snippet to see how you can call that API from Python or from JavaScript if you're developing in JavaScript, or if you just want to perform a curl request. So it's going through that router.huggingface.com endpoint. So Hugging Face inference providers is basically some kind of abstraction on top of all of those inference providers, with the benefit that then all the billing goes through your Hugging Face account. So if you have like an enterprise subscription to Hugging Face, which I think you can find here, yeah, then basically inference providers can be included in that. But so in that case, the AI is remotely. So the AI model is running on some remote server in the cloud, and you're sending your request to that server and you get your responses back. Very, very similar to the models from companies like OpenAI, Google, Anthropic, and so on. But so this video is actually a little bit different, because there the model will be running locally on our own laptop or on our own device. So people also call this on-device AI. And so in that case, there's no data that it's gonna leave our device. It's all gonna be happening locally, so it's gonna be fully private. So that's one of the reasons why people prefer to use open source models, for data privacy reasons. Because in that case, for example, the models from OpenAI, yeah, the weights are shared across hundreds to thousands of people all around the world, and they're all sending their request to that server. If you have sensitive data, for example, and you don't want something like that, then it might be useful to look at openly available models that run fully privately on your own hardware. Or, for example, what you can also do is rent a couple of GPUs on the cloud and then run the model on those machines. But then in that case, it's only running for you. It's not being shared with anyone else. And that's what I'm gonna do today. And I prefer actually to work in a UI. So with a UI, I don't really like to interact with large language models from the terminal. There are also some tools out there that allow you to do that. But I prefer working with a user interface. And I think LM Studio is a a great example of that. So I already downloaded LM Studio on my own laptop. And this is a bit the interface that you then see. So it's very similar to any other chat interface that you might have already used. For example, the UI of ChatGPT. Except here, what is different is that the model is running locally on my own laptop. So in this case, I downloaded the Mistral small 3.2 model, which recently came out from Mistral. Yeah, you can also see LM Studio then tags it, for example, in this case with the amount of tokens that the model can get as an input, and also the format. So yeah, that's maybe another thing I need to discuss if you want to fully understand how to get the best out of LM Studio. But first, maybe let me just start a new chat and see whether it works fine. I've noticed that it has some kind of cold start, like the initial question that I sent is always the slowest, and after that it becomes quicker. So I'm gonna ask it if it knows about Hugging Face, for example. So that's pretty cool. And so this allows you to chat with it fully locally, so I can actually turn off my Wi-Fi now and continue the chat. So in this case, for example, it says that Hugging Face primarily focuses on NLP, but I want to know if it also does other things. So as you can see, it's running fully offline on my own laptop. And it's nice that it knows about the other efforts that we've done at Hugging Face besides language models, which is quite cool to see. And then, so yeah, some things to note here is that on the bottom, you can actually select what kind of user you are. So if you just select here the user tab, then you only see your recent conversations with the model. You can actually also group them. If you create a new folder, then you can group your conversations in a particular folder. You can click on the plus sign for a new chat. But they also offer the options of power user and developer mode, and those are a bit more low level, because in that case, as you can see, I can go to the My Models tab to select different models, which is quite cool. In this case, as you can see, the model is taking up about 15 gigabytes of my MacBook memory. You can see the amount of parameters that the model has. So it has 24 billion parameters, which is oftentimes the size that people that work with local AI models prefer. Then this is the thing I will have to explain, the quant, which stands for quantization. And then, yeah, there's some more details which you can tweak over here. I think this is only possible if you select the developer option. So then you can also, for example, do GPU offloading, select the amount of threads if you want to run this on the CPU and so on. Actually, I don't really know whether this is running on my MacBook's GPU or whether it's running on the CPU. That's something to be checked. And then these are some relatively low level parameters regarding the model, which I'm not going to focus on. Oh, that's interesting. You can also show where it's exactly is downloaded on your laptop, so that's pretty cool. Yeah, I see there's a MM projection, so that's a multi-model projection, probably because the model is multi-model, so that's actually also another thing we could test. Whether it can recognize images, because the Mistral small 3.2 model is actually multi-model, so it should be able to also process images. So let me find sorry, the logo of Mistral. Again, to prove that we're going fully offline, I can just close or turn off my Wi-Fi again and upload this image. what do you know about this company, for example? Yeah, in the developer tab, you also see the amount of input tokens. Okay, the display is here a bit weird, but let's see. So it's processing the prompt. So if you move back to the Mistral, to the user tab, it says Mistral AI is a cutting-edge company based in France. I'm proud to be one of their creations. Okay, so that's quite cool. So you can copy it, you can edit it, and you can delete it. You can also actually modify the system prompt. So let's say you are a drunk person who makes grammatical mistakes. Let's see if the system prompt works by... Let's see if my system prompt still holds in the new chat. That's the case. Okay, how are you? I might be a little tipsy, but that's okay, right? So how about you? How's your night going? So yeah, that's quite cool to see that you can easily modify the system prompt as well. Tipsy chat. Then the appearance. So you can select here whether you want to view the markdown, view plain text or monospace. You can change the font size. So that's quite cool as well. All right. So that's like the main interface of LM Studio. But now maybe let's talk a little bit more about the developer tab and go a bit more low level regarding what you can also do with LM Studio, which is pretty cool. So for that, I'm gonna be going to the hub again because I want to showcase the model card. So if I go to Mistral 3.2 small, which is this one, yeah. So yeah, it has the 25th of June in its name, but that's actually tomorrow. But they released it like 4 days ago. So it's a minor update to their previous model, also called Mistral Small. This one was called 3.1. This one is now called 3.2. And they say it has some improvements in following categories, instruction following, so it's better at following precise instructions. It also produces less infinite generations or repetitive answers, and it is also apparently great at function calling, which is nice to see. Yeah, here are some benchmark numbers and so on. So they basically say that Mistral Small 3.2 is a drop-in replacement for the 3.1 model. And then, yeah, they recommend to either use VLLM or transformers. The transformers library if you want to use the model locally. And then you can go here to the file and versions tab. As you can see, the model weights are saved in this save tensors format. So save tensors is a format developed by Hugging Face themselves to basically safely store the weights of a model, because before that people were using the pickle format, which PyTorch also uses by default, and that's considered unsafe because people might add dangerous things in the files without you knowing it. But with saved tensors, that's not the case. So you can see that it's spread across multiple files, also called shards. So they shard or split the weights into smaller chunks, each of about 5 gigabytes large. So maybe, yeah, I can also bring up Excalidraw, which is a nice drawing tool, to basically compute the size that we need for this model. So by default, I think this model, if you go to the precision, so here you can see, for example, we have 24 billion parameters. So it has 24 billion trainable parameters. And the tensor type is B float 16. So the default precision, basically the precision is the amount of bits or bytes you use to store each of the parameter values, is BF16, so that stands for B float 16. So B float 16 can also be called half precision, because people used to train models in what it was called full precision. And so full precision or float 32, that would mean that you would use 32 bits or 4 bytes to store each parameter's value. Well, to store each parameter. So that's like full precision. And then you have half precision. And here you have float 16, but you also have bfloat 16, which is a format developed by Google Brain, because the B stands for brain. So there you would use 16 bits or 2 bytes to store each parameter. And then, yeah, you can go to, for example, 8-bit or 4-bit. So those are typically called quants or quantizations. 8-bit quantization. So that would mean that we would use 8 bits or 1 byte to store each parameter. And then with 4-bit quantization, you would only use 4 bits or half a byte to store each parameter. And based on the amount of parameters that we have here, so we have 24 billion parameters, we can now actually determine the amount of gigabytes we need to load this model for inference. So if we would have full precision, so 32 bits or 4 bytes to store each parameter, and we have 24 billion parameters, that would mean 4 bytes per parameter times 24 billion parameters. So that would mean that you have basically 4 times 24, which is 96 gigabytes, right? Because 4 times 24 is 96. So you need 96 gigabytes of GPU memory to load for inference, because you need to load all the parameters in your GPU memory. Of course, if you have 2 GPUs, you can like split the parameters across these 2, but still, like with a single NVIDIA A100 GPU, for example, that has like 80 gigabytes of memory, so that wouldn't fit in a single A100. So that's pretty crazy. So we only have a 24 billion parameter model, and it doesn't fit in a single A100, because in full precision it would require that much amount of memory, 96 gigabytes. But so luckily Mistral trained it by default in half precision, so we can actually do the same calculation, but so of course it's going to be the same, but divided by 2, so that's 84 gigabytes of GPU memory. Still a lot, but that means that you can load it on a single A100 in half precision. You don't need to do any quantization. So yeah, basically the lower we go here, the lower amount of bits we use, we call that the process of quantization. You basically quantize the weights. So what I mean by that is basically we only have certain ranges of values that the weights can use, that they can take up. Whereas with full precision, they have more freedom to have more different unique values. So you basically restrict the amount of unique values that the weights can have. And so typically, the more you quantize the weights, the less memory you need, of course, to store the weights, but also there is some performance degradation. But there are some clever quantization algorithms out there. So you can actually find this in the Hugging Face docs. There are some clever quantization algorithms out there that try to basically ensure that the performance degradation is as small as possible. And sometimes it's even on par with a full or half precision model. So as you can see in the transforms library, there are multiple quantization algorithms supported. Here are all the quantization methods. As you can see, there are now quite a bit. I'm mostly familiar with the bits and bytes quantization, because this is also actually a library that is maintained by Hugging Face themselves. And this greatly, of course, reduces the amount of memory that people need to load these models. And it's fully compatible with the Transformers library. So here you can also see what are the things it supports. So it's supported in Transformers. It supports PEFT fine-tuning and so on. Parameter efficient fine-tuning, where you would like quantize the weights of the base model and then train some adapters on top, but that would be a different video. So yeah, that's the process of quantization. And there's actually a very good blog post on it. So if you Google Hugging Face quantization blog, yeah, you can find all kinds of very nice blogs on which explain basically what is quantization. So here, basically the same thing as what I explained. So as you can see, the ranges differ because, for example, with 8-bit quantization, you only allow these kind of values for the weights and so on. Yeah, I highly also recommend out this blog post if you want to know more about bits and bytes and so on. So yeah, let's say less memory, but also slight performance degradation. That's happening when you shrink the amount of bits used to represent each parameter. So let's continue our table here. So the next one is 8-bit quantization. So that's again divided by 2. So we only need 24 gigabytes of GPU memory. And then with 4-bit, and that's actually what we are using over here. So yeah, this would be like 12 gigabytes of GPU memory. But actually one thing we also need to take into account, typically it's not just the amount of parameters that you need to load into GPU memory. Most people say you also need to like multiply it by, let's say a factor of 20% extra, because you have some additional space that you need for like the activations of the model. And also, yeah, the longer the context window you want to support, of course, the more memory you need. So that's why we get here 14.4. And this explains why LM Studio is now taking up about 15 gigabytes. It's actually a little bit even more, 15.21 gigabytes. So maybe we can do this by 1.4. Okay, that's even okay, so it's about 1.2, 1.3 that you need to take into account as additional overhead when working with a model locally. So let's say about 15 gigabytes of GPU or CPU memory is required to run the model locally. And so what it means is if we're running this Mistral small 3.2 model over here, we are using the Q4, so that's the 4-bit quantization. And the quantization method being used here is called Q4KM. So that actually comes from the GGUF format. So GGUF is actually the format that is often used when we quantize the weights into a smaller amount of bits. So this was actually developed initially by the creators of the Llama C++ framework. So Llama C++ is one of the most popular frameworks out there. It's open source, which allows you to run all of these large language models locally. So they have basically implemented all these models from scratch in the C and C++ programming languages. And this all started with the Llama model, which explains the name. And nowadays they support all kinds of models from DeepSeek, Qwen, Mistral, and so on. And so they all rely on that GGUF file format to efficiently store the different quantizations of the weights. And so you can actually also filter the hub on that. So if you go to the models tab here, I think here on libraries you can filter for GGUF files. And I think the one we are actually using behind the scenes is this one. So Unsloth is a company which offers some very nice software for fine-tuning and quantizing large language models. So I highly recommend you to check out Unsloth if you want to fine-tune a large language model on your own custom data. So they have like the best scripts for that. And they're also known for like creating very good quantizations. So they call them dynamic 2.0 GGUFs or dynamic quants. So they basically find like the best ways to quantize the weights. They decide, for example, okay, these weights maybe don't, it's better to not quantize them because these are like very critical for the model to work very well, and then they quantize less important parts of the model. So I'm pretty sure that LM Studio is using this model repo here from Hugging Face, because this one is like the GGUF version of the Mistral 3.2. So this was like the original repo from Mistral AI, but as you can see, the files and versions tab only includes the safe tensors in half precision. And so Unsloth took these weights and turned them into all these GGUF files, which are like different quantization methods. So you can see the Q2. So this is an even lower quantization where you go to 2 bits. So there, yeah, the performance degradation might be a bit too much. Then there's Q3, Q4. So in this case, we are using the QM version of that. So that's this one. And as you can see, the weights themselves only take up 14.3 gigabytes. But then, as I said earlier, the overhead, because of the activations when the model is generating some text, you have some additional space that it takes up. So that's quite interesting. And this is a bit where it comes from. Yeah, and then there's also still a difference here. So you have, as you can see, between the 4-bit quantizations, you still even have some variance. For that, I would have to dig a bit into the different quantization methods that are created with this GGUF format. But here in this table it's actually explained in detail. But yeah, maybe that's a bit too low level, but here it says, like, for example, it uses super blocks with 8 blocks. Each block has 32 weights, and then they use some kind of formulas to explain how the quantization is being done. But that's for a different video. So that's basically a bit behind the scenes regarding why this model is taking up about 15 gigabytes in size and why we're using the 4-bit quantized version of it. So apparently they also support text embedding models besides large language models. So you can also find these on Hugging Face. So if you go to the models tab and you go to the tasks filter, then you can filter on, for example, feature extraction. And this is like typically what is used for embedding models. So right now the Qwen3 models, the embedding models from Qwen, which is from Alibaba, are among the best openly available embedding models. So again, here you can see some people already created quantized versions of them. So yeah, if I wanted to use an open source embedding model, this would probably be my favorite today, but of course this changes every week. And I think you can actually also then try out embedding models right within LM Studio. And so here they have this model discovery tab where you can actually find all the models. So yeah, this was the one I downloaded from Mistral, because this is among, yeah, it's also the staff pick. So the team from LM Studio also selects some of the models I think that they recommend to use, and Mistral Small 3.2 is currently at the top. So this is the main reason why I'm using it. So I would definitely recommend checking out their model catalog if you don't really know which model to use locally. And also, of course, it depends a bit on the amount of memory. But yeah, these are the staff picks, as you can see over here. So this is currently one that I would recommend. And then behind the scenes, so what framework is actually used behind the scenes? Well, LM Studio supports 2. So Llama C++ is one that I already explained a little bit. So yeah, and I actually think they are using the M2 or M3 chips if you have them, or the M1 chip. So if I go here to my max settings, I have a M1 max chip. So that's what is probably being used to run this model on. And then they also support MLX, which is a framework developed by Apple. So that's really aimed for running models on MacBooks or on Apple devices. So yeah, I could also choose the MLX version of a model. But right now, for example, if I go here to this Mistral small, so as you can see, it also supports vision. It's a bit unclear to me whether Llama C++ or MLX is being used here behind the scenes. Here I can actually filter only GGUF or also showcasing MLX. Here LM Studio knows about my hardware. So as you can see, I have one CPU. So actually, yeah, I'm a really noob when it comes to hardware, but so the Apple M1 chip is a CPU, has an ARM64 architecture, and then this is the RAM, the memory. And then as you can see, I also have a GPU in my MacBook. And so it has about 20 gigabytes of VRAM. So I assume in that case that the CPU is not being used. So yeah, you can actually see that over here. So it's running that, I assume, on this GPU that it has detected. Okay, so that's quite nice. And then the final tab I want to discuss, because this is very cool, I think, is that LM Studio also exposes your model with an OpenAI compatible API on your own laptop. So that's super cool. So what I mean by that is basically you can allow here to either stop or run that model locally. So it's reachable at localhost port 1234. And this is something I already tried out once. So what you can actually do is you can just open up an OpenAI connection with your local model. So you can then use your model as if you're using an OpenAI model, except it's running locally. So you just need to provide the URL here, and then you can just start chatting with it. Of course, I have to update my model here because now I'm using the Mistral model. To be honest, I don't really know whether that's that important because I think the most important thing is that connection. But now maybe let's try it out. So I'm gonna comment this out because for now I just want to showcase a simple call to the OpenAI API. So for that, yeah, we'll have to create a virtual environment to install the OpenAI package. So pip install OpenAI. So here we give it the system prompt, please always answer in rhymes, introduce yourself. So let's see whether it can work fine with that. So in this case, it should be sending a request. Okay, so here now it comes with the ready. Okay, so here it has received my request. And then it starts responding in the terminal. So here it says response in the realm where thoughts take flight. I'm an AI, a guiding light with words and verses. I engage in rhymes and rhythm. I engage. Okay, that's not the best rhyme. From questions simple to complex, I aim to bring you knowledge, no less. So let's embark on this journey you see. Together we'll explore. Just wait and see. Okay, yeah, I got a better rhyme, I would say, with the Llama model from Google. But it's pretty cool that you can now actually just call the model as if it's a closed source model. And then yeah, I got that snippet from here, the quick docs, because here they actually explain. Yeah, you can always test, for example, whether the local URL is running fine. So as you can see, it seems that there's also a text embedding model available over here. And then you can go to the chat tab. So here they showcase how you can do it with curl, but I prefer using the OpenAI SDK. And then they also support structured outputs. So that's the next thing we could try. So here, what I'm gonna do, so I'm gonna maybe comment that over again. Okay, I still need the messages. Okay, so here, for example, we could ask it, please tell a joke. And then you provide a JSON schema so that it's, for example, respects the schema that you want it to return. So let's try that. So in this case, it returns a dictionary with a single key called joke. Why don't skeletons fight each other? They don't have the guts. And neither does their dog, because he's just a little too soft. Okay, that's an interesting joke by Mistral. And then the final thing we can try. Well, there's actually two more. There's tool use, so function calling is also supported by these models. And yeah, Mistral is saying that their model is optimized for it, because that was set in the model card. So here, let's say we have a tool for fetching content from Wikipedia. So we give it that name, the description of the tool. So it's a tool to search Wikipedia and fetch the introduction of the most relevant article. And then it only needs to provide a single argument called search query. So what I did here was I asked the question, how old is Cristiano Ronaldo? So I would assume that it calls the tool with argument Cristiano Ronaldo. So let's try that. Yeah, it has access to a single tool. I think you could also here specify tool choice auto, whether it can like dynamically decide whether to call the tool or not. Okay, in this case, I'm getting a non-type. Let's see why that is. So the messages, oh wait, okay, that's okay. The messages that we provide here. Okay, so we get this response from the model. I'm sorry, but I don't have real-time data or the ability to browse the internet to find his current age. Okay. So what I could do here is set the tool choice to required, and in that case the model is forced to perform a function call. So that's interesting because in this case, as you can see now, it calls the function called fetch Wikipedia content with the search query Cristiano Ronaldo. With the Llama model, for example, I also it performed the tool call right away. So that's interesting. So you can start experimenting with these different models locally. And then the final thing it also supports is vision input. So what we could try is go to the OpenAI docs and then to the vision part of it. So I think this is what we need. I'm gonna try that maybe in a separate script. So the only thing I have to change here is the client and then the model. Like this. Okay, and then I can ask what is in this image. So here, this is taking a URL as an input, but we want to provide a local image. Let's see what it does. Okay, so here it does not recognize file paths, so images must be encoded in base64. Okay, interesting. Well, let's maybe just try this to see what it gives. Because I think it must be a base64 encoded image, and that's apparently not the case here. So what we can try here is maybe provide a sample URL. Yep. like this. Wait. Let's see, so this is already closed. Like this. Okay, and now it should be able to process that image. But I think in the OpenAI SDK they also explain how to pass local images. Yeah, here passing a base64 image. So that's how you can like rerun it with local image. But as you can see, it says I can't directly view or analyze images. However, if you describe the image to me, I'd be happy to help interpret or provide information based on your subscription. That's interesting. Normally, it should be able to support images as well. Maybe there's an issue with that. Yeah, because it's like in the UI we are able to pass images. That's what we did already with the Mistral logo. So that's interesting. Maybe one final thing I can try is this here. Where I will pass the local Mistral logo image. So let's find the Mistral. Okay, I already downloaded it. In that case, I can just go to my downloads. Let's try that. Let's see whether it's now able to process that image and understand it locally. So now it's sending a request. Let's go back to the developer tab here. Okay. In this case, it says the image contains a logo with two main elements. Stylized H composed of geometric shapes. The text Mistral AI written in black with AI partially visible. This appears to be the logo for Mistral AI, a company that develops large language models. All right, so that's quite cool. So yeah, as you can see, it works, and it works fully offline. So let's maybe take another image that I have locally. This one is from Andrej Karpathy, so I'm pretty interested what it's going to do with that. It's like a slide from one of Andrej Karpathy's recent talks, so I'm interested in seeing whether it can read all the text. Maybe I can also change the prompt here. Please OCR the image and write all the text line by line, or read all the text line by line for me. Alright, so now I'm curious. It seems that the response has already been appearing here in the LM Studio app, because here it's saying the image appears to be a slide from a presentation discussing the properties and utilities, but it takes some time before it also appears here. Here's the text extracted from the image. Okay, so maybe let's open that image and hold it side by side to see what it says. Here is the text extracted from the image. CapEx to train an LM to build the grid, OpEx to serve intelligence over increasingly homogeneous API prompt image tools, metered access, and so on. So image also contains a graph titled LLM rankings, so that's indeed true, with various colored lines representing different models or services and their performance over time. One of the lines in the graph is labeled open router. So yeah, that works fine. So that was just a short demo to showcase what you can do with local AI models, with LM Studio, with the GGUF format, with things like Llama, C++, MLX, and the OpenAI compatible API. So I hope you learned something, and see you in the next video. Bye bye.